Moving on to our next session, we have Mr. Ashish Agarwal, Global Director, Digital Innovations and DevOps Transformation, and Mr. Swaroop Rajendra, Test Consultant Specialist from CSG. A quick info on Ashish. With over 23 plus years of experience, Ashish is currently the Global Director, Solution Innovation Group in CSG, bringing in disruptive product and process innovations via applying emerging digital technologies, as well as leading the organization-wide DevOps transformation journey. Ashish has been delivering innovative solutions, solving complex business problems for worldwide clients across America, EMEA, and APAC regions for businesses in telecommunications and financial services. Ashish is proficient in setting up from ground zero large global innovation, transformation, and delivery practices with culturally, geographically diverse multi-product and multi-vendor teams. A quick info on Mr. Swaroop Rajendra. He has over 9 plus years of experience as automation developer and software tester in the areas of order management and telecom billing, with more than 6 plus years of experience in automation testing. Swaroop is a machine learning practitioner with PG Diploma in Machine Learning from Great Lakes. As test consultant specialist with CSG, he works on delivering complex automation solutions for multiple client accounts. Leveraging cognitive automation through machine learning, AI, Swaroop has delivered multiple innovative solutions in software development, testing, and operations. He's also the leading team for development of ML-based telecom product recommendation system. Well, their topic for today is machine learning, ML-based incident or defect turnaround cognitive processor.
Hello friends, today we are going to talk about the machine learning based incident or defect turnaround cognitive processor. So let me introduce to the speakers. Myself, Ashish Agarwal. I am the Global Director with Solutions and Innovations Group within CSG. My interest areas are digital products and process innovations, as well as DevOps transformation journey. I have 23 years of experience, and I have with me Swaroop Rajendra, who is the test consultant specialist in the Solutions and Innovations Group at CSG. And his interest areas are machine learning and cognitive automation, as well as he does a lot of process level innovations and has around 9 years of experience. So let's quickly see the agenda for today's talk. We will start with the traditional incident or defect management system. Then we will touch base around the challenges for faster incident or defect turnaround. This will be followed by a machine learning based solution which we have come up to address the challenge, as well as we will see the business outcomes that are delivered for the delivery or the operations team, and what are the adopted DevOps practices in the business implementation side. We will see the solution evolution journey, how we have evolved this solution using DevOps techniques, and actual implementation of this solution in life to the actual delivery. The results that we have got across in one of the accounts will be shown across. So let's see the traditional incident or defect management system. We have the defect management tool here and the development team. The defect is absorbed by the development team and a resolution is updated back in the tool. Similarly, on the operations side, we have the incident or ticket management tool, and the operations team absorbs any incident or the service request or the ticket, and they send across the resolution update. So that's a incident or defect management system that has been existing for around 2 decades with us. Now let us see the challenges for faster incident or defect turnaround. The reality of any organization is that it is composed of medium experience level folks and junior folks with very scarce or less experts or SMEs within the organization whose time is really precious. Further, we have the teams which are geographically spread across Americas, Kala region, or it could be in Europe, Middle East, and Africa, or Australia and the APAC geographies, because we operate in follow the sun model for our deliveries as well as operations. There are too many handoffs between the team members. So typically incidents, defects, or service requests or tickets gets ping pong between the team members. And this results into a massive delays. There are huge amount of fluxes in the defects or tickets which come across because there's nothing even out there. So that results into at times in a long queue size or work in process. That again delays our resolution turnaround. There is a massive time pressure with this agile and DevOps world that we operate into, with stringent SLAs as well as massive delivery turnarounds for any defects in our delivery cycles. And we have a very loosely coupled teams with massive silos within the organization who are working in various accounts, and there is no kind of a reuse across the organization. So net in all, this results into massive challenges of toil for the team, whether it is the delivery team or operations team, and hardships. So that results into a huge team anxiety and possible burnaround. On the other side, you may have a screaming customer because they want things to be turned around faster. So we have come out with the solution to really have these resolution of defects or tickets or service requests or incidents faster while leveraging the resolution of the past historical incidents or defects that are there available within the account or organization, and thus solve these tickets or defects or service requests faster. So let us now see what is our solution. Our solution is a stack of machine learning algorithms, which on the runtime gets trained via a volume of tickets, defects, or service requests historically that are available inside the account or the organization, and they result into a trained machine learning model. This machine learning model, when fed with a new defect, incident, or service request, results into a decisioning engine which really processes to produce an output of similar tickets, defects, or incidents or service requests in the descending order of the similarity with the new item that has come there. So now let us see this machine learning based solution in more detail about how it works in an end-to-end flow. And I will hand it over to Swaroop, who is going to walk us through this flow.
Thanks, Ashish. As we all know, we have a lot of tools or applications that are available in the market today. It can be for incident management or defect management or for a service request management. So we have a lot of tools and applications that are available today. So what we do is we continuously stream the historical defects or incidents or service requests. Let's say for past 6 months, or based on like how much of defects we have or the incidents we have in the system, and we feed it into a stack of machine learning algorithms. So our stack of machine learning algorithms, learning from this data, will result in a trained machine learning algorithm. So what will happen is we have our development and our operation team members sitting on the other side. When they get a new incident, defect, or a service request from any of the applications, they take it as an input and feed it into our trained machine learning model. So our trained machine learning model analyzes the details that has been given to the trained machine model. It will understand, it will analyze, and it will categorize, and then it will try to give you the similar historical defects from the past, looking at which I can learn about the incident or a defect or a service request. I can learn from the past resolutions that were given, and I can fix my incident, defect, or my service request and update my any of my tools or applications accordingly. Also, we have a corrective feedback mechanism in place, so that like in case if the trained machine learning model is not able to give, let's say, appropriate recommendations or suggestions, so we can monitor them, and we can we can tune or further fine tune our machine stack of machine learning algorithms, so that such inappropriate suggestions or recommendations are not given out by our trained model. So this is how our end-to-end flow looks, and this is how our ML solution is fitted in. And then now let's look into the ML solution detailed architecture. So as I said in the previous slide, we have a lot of tools. So what we do is we extract the data from such tools or applications, and we store it in a database. So the data that we have extracted is now sent into a natural language processing algorithm. So the natural language processing basically converts our textual data into a numerical data, which is used for training our classification algorithms. So also we use that natural language process data to also train our similarity algorithms. And the final outcome after training this stack of algorithms is a trained machine learning model. What we do is we give our details of our current defect or incident or a service request via our Angular GUI, as you can see here. Let's say example sim swap failed with some error. That is the input that is given from our Angular GUI, and that is fed into our trained machine learning algorithm. The algorithm analyzes the incoming detail. It'll basically classify it. It'll also, after the classification is done from the classified bucket, it will try to get you the historical defects, incidents, or service requests from the past, which we can leverage to resolve our current incident, defect, or the service request. So this is the ML solutions detailed architecture. All right. So we have the solution output here. This is how our output of our machine learning solution looks like. So we have hidden some details over here, taking account of our organized data confidentiality. So we basically show our output in a tabular format, as you can see over here. First column, we have the number column, which is nothing but the defect number, defect ID, or an incident ID, or a service request ID. So followed by the open date column that gives us a date when that particular incident or a defect or a service request was logged, and followed by the short description of that incident or the defect, and again by the long description and category, subcategory, symptom, the solution, and the score. So here the category and the subcategory is nothing but the category and the subcategory to which the defect or the service request or incident belongs to. And the symptom in our case is nothing but the known documented procedures that our team had used to in order to resolve those requests. And then what kind of a solution was it? Was it like was any found fault was found, or was it a known issue that they fixed it, or it was more related to user education that they educated the user to use the application in a proper manner? So these are some of the details that we show in our solution output. Also, we have this score column, which gives us the similarity or the matching score of our incident or defect or a service request detail that we had entered previously into our application versus the description or the incident or a short description we have in our output over here. For example, let's say the first incident is over, or the defect what we are seeing on the screen right now is like 83.36% similar. That means our current defect, incident, or the service request which we are trying to currently resolve is near matching with our first incident or defect in this list by 83.36%. So this will give me a starting point by referring to which I can learn from the historical previous defects or incidents, and I can learn from the resolution or the solution they had given back then, and I can quickly resolve the incident. Now let's see how the solution, how the output of our solution, ML solution, looks like. So generally we show the output in a tabular manner, what you can see over here, and we have hidden few details over here based on our data confidentiality. Generally we show the first column like the number, that is the defect ID or the incident ID or a service ID, followed by when was it open and the short description of it, followed by the long description or the detailed description in other words, and followed by the category and the subcategory that particular incident, defect or the service request belongs to, and the symptom, the solution and the score. So what does the output mean over here? So what we are trying to send is like, based on the details that I inputted, I gave as an input into my application, it is trying our application is analyzed it, it has classified it, and then based on the similarity it is listing the results over here, looking at which I can quickly find out, or I can find the historical defects or issues, and I can refer to which, and I can also learn from it and quickly resolve the incidents or the defects or the service requests I'm currently dealing with. So this will give a starting point to me from where I can learn and I can move ahead instead of relying on any other senior member in my team or a SME in my team. So this is more of a self-service knowledge base for me as well.
Okay, thanks, Swaroop. That was very good. Now I will walk through the business outcomes that have been delivered via using our solution, any of the delivery or operations and projects here, and what are the adopted DevOps practices. So via this solution, the mean time to resolve any ticket, defect or service request is reduced, as well as the queue time or work in process gets reduced. On the other side, the tickets or defects or service requests getting resolved in the first time increases. So percent complete and accurate on the DevOps terms is increasing. We have elevated our local discoveries or local knowledge globally via this solution, because any incident or defects that were lying in the historical manner, even 5 years behind or 6 months behind, have been surfaced out to solve any new incident, defect or service request. Similarly, this has resulted into killing of fixed mindset across the organization, and it is resulting into growth mindset culture with I-shaped skill set turning to T-shaped skill set on the knowledge basis to pi or E-shaped skill set. So more of people are adapting to knowledge in the areas where they are not, and it's like getting into a generative culture. On the other hand, we have self-service knowledge buddy being acted via this solution for any new joiners or even the existing team members which want to work over in other areas apart from their regular areas. So that increases. We have reduced the odd hour calls to our experts or SMEs, and more of dependency on them in a massive way has been reduced because it's becoming more of a self-service solution. The handoffs between geographically dispersed teams has reduced because people are able to use this and resolve it on their own, any incident, defect or service request. There have been quite a good catalyst function via this, using this solution, which acts more as an accurate and speedy resolution for any of the tickets, service request or defects. And it acts more as a on-demand solution tool available 24/7 at the desk of the team members. So this solution supports all three ways of DevOps as described in the DevOps handbook by Jen Kim. So it supports the first principle of flow, that is systems thinking, much faster flow from in the value stream from development to QA team to deployment to operations and to the finally end user. Also in the value stream from operations to end user, in the case of operations support, it supports therefore via doing a faster resolution. So the entire flow velocity increases. The second principle it supports in the business via giving a proper pinpointed feedback for resolving any of the defects, incidents or service requests. So it is really speeding up, at the same time it's giving the right feedback to the team members. So in both the value streams that I told, that is also helped via this. Third principle of continual learning and experimentation is met via promoting growth mindset, promoting it more as a self-service portal available for consumption by new joiners or anybody in the existing team, geographically dispersed across, as we saw in the last slide. So it does support all three ways of doing DevOps to the business wherever we implement this tool. So let's get to the solution evolution journey using DevOps techniques. So what we saw in the last two slides was how this solution is helping the business, which is, actual delivery teams or the operations team, to turn around the resolutions faster. In this following slides, I'm going to discuss across the actual solution evolution journey, which we have used via DevOps techniques. So any innovative solution that you bring across doesn't come easily in a day's time or in a few days' time. It really requires a lot of experiments to be done across. And we also performed 3 major experiments. In the first experiment, it was a self-member, the one who was building the solution himself was using it across. In the second experiment, it was more of a project L3 team, which were using this, and we brought that solution to them. In the third experiment, which we did across with the data and then implemented it to an account service request team. And that's how in these 3 experiments, and finally after the third experiment, we have been successful in implementing within that account team. In the first experiment, we were focusing on getting an open source utility as a plugin which was more of Jira specific. Jira is our defect management tool. So that is what we were looking at there. Now, this resulted into a very tight coupling to one of the tools only. And further, it didn't give us a flexibility to do a lot of changes in the plugin, because it was something that we were having it built across specifically for Jira. We overcome this in the second experiment via bringing a stack of machine learning algorithms and a simple HTML-based GUI to use this solution. In the third experiment, we further refined our machine learning algorithms and brought a smarter, latest Angular-based GUI. So all in all, this resulted into loose incident or defect tool coupling, as well as progressive technology advancement in all these 3 experiments. So these are 2 DevOps techniques which we have used here to evolve our solution. Now, in the first experiment, there was a Jira database, but since we were directly using the Jira database, it could result into a massive performance stability risk, because we would have done a lot of queries in the database to find the resolution for the defect that we were looking there. So we got a read-only access into Jira, and further there was a team member given from the Jira admin team, where our team member was doing massive handoffs for any tuning, solution evolution, or debugging, or analysis. So the progress was very slow. How did we mitigate this? We actually had a separate database coined out for our machine learning, and we had a streaming from either the defect management tool or the incident management tool in the experiment 2. Same thing we carried over in experiment 3. So this all from DevOps perspective, it resulted into mitigation of the handoffs and production tool stability risk. That is what we mitigated by using these DevOps techniques. Now, this was used in experiment 1 individually by the person who was building this solution as well as using. So there was no question of feedback out there. In the second experiment, this was used by a couple of users in one of the accounts by their L3 team. So there was a weekly user meeting which we had set up, but that was slow as a feedback. So no excitement and no real enthusiasm to take up the adoption. In the third experiment, we set up daily stand-up meeting where there was a faster feedback which came out from the adoption team of the service request team, as well as we turned around the solution changes that they wanted across in a day's time for our Angular GUI, which is typically a system of engagement, or in a 3-4 days time for our backend algorithms or the database, which is our system of records. So in the DevOps techniques terms, this resulted into a progress towards faster user feedback, which is the second principle of DevOps, or quicker solution changes, which is the first principle of DevOps, faster delivery in the value stream. Now let's see the volumes of defects or tickets or service requests. We had 2 new defects per month in the first experiment. So we did not use the machine learning here. We had 6 new tickets per month in the second experiment. The machine learning training data was 850 tickets here. In the third experiment, we had around 2,000 new service requests per month, and the training data was typically 20K service requests. The first experiment used by the self person who was building and using it, no urgency. The second experiment had low urgency. The team had to be pushed across to really use the solution. In the third experiment, there was a high urgency because this team had really massive volumes of service requests prior to us bringing the solution. They were struggling with 3,000, 4,000 service requests a month. So there was a high urgency to get any solution which really helps their pain point of resolving the service request faster, resulting into a huge team autonomy and a self-pull for any solution. So there was a massive collaboration that we got from this team, and that helps us to bring the solution faster to that team. So in DevOps techniques, we failed fast, and we had a solution early adopter to be rightly chosen for maximum outcome and maximum adoption across the organization. Now, as we know that there are 24 key capabilities of DevOps, which have been listed in the Accelerate book by Nicole Forsgren. These 24 capabilities you can see are listed on the slide under continuous delivery capability, architecture and team capability, product and process capability, lean management and monitoring capability, and cultural capability. Out of these 24 capabilities in our solution evolution journey, we have used these 15 capabilities, which are highlighted in the color black here. So those have been used across. The thing to note here is all 5 capabilities which have been listed in that book on the cultural side have been implemented. So that is the kind of a culture change which we have brought across via evolving this solution. Now, this is a verbiage from the book, The Phoenix Project by Gene Kim. Until the code is in production, no value is actually being generated because it's merely work in process stuck in the system. And the same applies to our solution. Till the time we bring this solution into production, which means till the time we bring this solution to usage by our delivery and operations team, it is really work in process stuck and it's not realizing the business value. So that's what we have done it across. In one of the accounts, we have brought it across, and we will see now how the solution implementation results have come through from that account. I will hand it over now to Swaroop, who is going to walk us through those results.
Yeah, thank you, Ashish. So before we move on, first we would let's understand what is the definition of a resolution time. It can be a defect, or it can be an incident, or it can be a service request. So let's understand what is the resolution time. So resolution time is nothing but the time that is elapsed since the service request or a defect or a incident got created in the system till that incident or a defect or service request got closed. So whatever the time is elapsed between getting created and getting closed, that is our resolution time. And as part of the resolution time, we have 2 more components, that is the queue time and the process time. So first, if you look into the queue time is nothing but the time the incident, defect, or a service request that has spent idle before an engineer or a development member or an operations member has picked it up and started to work on it. So that is the queue time. And if you look into the next item, that is the process time. The process time is nothing but the time the engineer or a development or a operations member has taken to work on it and finally close the request. So that is the process time. So in short, the resolution time is nothing but the sum of queue time and the process time. In one of our accounts, when we implemented our ML solution, what we did, we wanted to compare the results. How well is our ML solution working? So, and what we did is we calculated the average 6 months service request resolution time without ML solution before the ML solution was implemented. So when we calculated the average service request resolution time, it was 283 minutes. Everything is in minutes here. So it was 283 minutes it took for an average resolution time to fix any service request. So After that, what we did is we calculated the average service resolution time when our ML solution was implemented, after our ML solution was implemented, and the results are evident. We could see the drop in the average resolution time, and it was the average resolution time when for any resolving any service request was 85.93 minutes. So we had a good, we had a the average resolution time dropped, and that resulted in less work in progress. The queue time was reduced, and the mean time for resolution was also reduced, and then order work calls to the experts was reduced. So we had a lot of benefits from that, which were documented from that account after the implementation of our ML solution. So this is our end of our presentation. So I would like to thank the DevOps India Summit for giving this opportunity to present our work and also to share our work with all the folks.